Okay, we're going to look at Chapter 11, look at managing bond portfolios. A relatively short chapter, but it's kind of packed full of, I think, good stuff, but it is relatively short. So one of the risks involved in owning bonds is interest rate risk. Yields and bond prices change as the market rate of interest changes. So we're going to talk about different types of bonds, how they're sensitive, what the relationship is with the market rate of interest and other elements of the bond market. So there's kind of observations that have happened over the years about bonds and what their relationships are and how they react to different elements of the market. So interest rate sensitivity, bond prices and yields are inversely related. So that means as yields go up, prices go down and vice versa. So that's an inverse relationship. An increase in bond yield to maturity results in a smaller price change than does a yield decrease of equal magnitude. So effectively, we're saying that a yield decrease versus a yield to maturity has a greater effect on the pricing of the bond than the yield to maturity itself. So while the relationship is what we stated it was, the magnitude of change differs. Long-term bond prices are more sensitive to interest changes than short-term bonds, which makes sense to an extent, at least, because shorter-term bonds, the shorter something is, the less risk we generally have, because we generally have a better idea of what's going to occur in the near future versus the long-term future. And also, the more interest payments and more trading of the bonds are going to happen, the longer term the bond is. As maturity increases, sensitivity of bond prices to changes in yield increases at a decreasing rate, which sounds really confusing, but as maturity increases, so the longer term, if there's a longer term of a bond, the sensitivity of the bonds changes in yields increases, but as it goes on, it doesn't increase as much, so at a decreasing rate. As maturity increases, sensitivity of bond prices changes in yields increases, but again at a decreasing rate. Interest rate risk is inversely related to the bond's coupon rate. Low coupon bonds are more sensitive to interest rates. Why? Because, well, lots of reasons, but the one that comes to mind for me is the fact that there's a smaller differential between the market rate or even the risk-free rate. When you're talking about a low coupon rate, the comparison to the risk-free rate versus the coupon rate is relatively small. So that means that they would be more sensitive to interest rates because the percentage of change affects them in a larger way. So the sensitivity of bond price to yield change is also inversely related to the current yield to maturity. So this is pretty much what it looks like with regard to the graphic representation of this of the statements that we just made. So you can see we have bonds A through D, and then we have coupon rates 2 at 12% and 2 at 3%. And then we have a shorter term yield to maturity for my A bond versus 30 years for B and C. And then I have an initial yield to maturity of 6 for D. And so you can just see that this is basically a graphic representation of the fact that the slope of the line changes and the fact that it's actually a curve, I should say, in this case, are actually curves. And that when you see a curve, that's those statements they're making about that it decreases but at a decreasing rate, or increases but at a decreasing rate. That's generally the flattening of a line, is what we're talking about there. So this is the change in percentage points for yield to maturity, and this is the percentage change in bond price over here. So interest rates versus coupon rates and sensitivity. So this is a bond year yield to maturity is 8%. T1 at year 1, T10 is 10 years, and T equals 20 years for this one. So we got 3 different bonds: 1-year bond, 10-year bond, 20-year bond. And an 8% bond, that must be the market rate, which is why the $1,000 goes all the way across the board. Then we have our 9% bond. But notice as the time goes, as the length of yield to maturity or bonds maturity time frame gets to be longer, the percentage change in price gets to be more and more drastic. So that's what we've graphically seen already. And then zero coupon bonds are similar, but actually are even more drastic. As you can see, we have a higher percentage of change once we go from year 1 to year 10 versus year 10 to year 20. So the marginal difference is more substantial, quite a bit, especially when we go from 10 to 20. But see, it's at an increasing rate that it changes from 10 to 20 versus what we see from 1 to 10. Oh, I'm sorry. This one is an increased rate, but notice this one is a decreasing rate of change. So from years 1 to 10, which is a 9-year term, we've got a just under 6% difference, 5.5. But here we're at less than 5. Okay, so there's that decreasing rate we talked about in the prior one too, in the prior slide. Okay, Macaulay's duration. This is the measure of the effective maturity of a bond defined as the weighted average of the time until each payment with weights proportional to the present value of those payments. So this measures the effective bond maturity. So this is our method we can use to figure out what the interest rate risk is relative to the maturity of the bond as it relates to the maturity time frame of the bond. So this is a spreadsheet they have built in the chapter on page 331. So you can see an interest rate. So this would be what we would also refer to as a market rate. Then we have an 8% coupon bond and a 0% coupon bond. And you can see the payments, payment discounted, and we can see our discounts and our discount rates. The payments discounted at 10% is $950 because the 10% interest rate is higher than the 8% bond rate, which means we're going to have to sell this bond at a discount. So there's a discounted bond. And then over here we have effectively the weights of each individual payment. What they did here, though, is they separated out the payments themselves to find the present value. We did this in the prior chapter with Excel and finding the present value function of each individual payment by itself. But this extends that thought process. And I like this because it shows you obviously the difference between a 0 coupon bond versus an 8% bond and what kind of difference we see in the weighting and what the discount would be. And then also down here, you can actually build this spreadsheet pretty easily because they've shown you on the bottom part of this, if you want to build this spreadsheet and you want to look at what this is and how this works, this is the method to do so. And the other cool thing is if you build this, you could perhaps use this for homework or other problems because you can have your market rate of interest, and assuming you keep all your formulas the same, I'm not going to rebuild one myself because I think they've done a good job in the chapter of showing you how to build it. But that would be good. I think that would be a wise spreadsheet to build if you have the time. Like I said, I think it's a useful one to have. All right, the change in bond price versus the yield to maturity. So this is effectively what the Macaulay's duration is mathematically. It's what this shows. And then we have a modified duration, and this is more what practitioners use more often. So the percentage change in bond price is the product of the modified duration and the change in bonds yield to maturity. So we got change in price, the duration, and change in price 1 plus y divided by 1 plus y. So the proportional price change equals a proportional change in 1 plus the bond's yield. The y stands for yield, obviously. Therefore, the price, a bond price volatility is proportional to the bond's duration, and the duration becomes a natural measure of its interest rate exposure. And this is effectively mathematically showing, like I said, it's mathematically showing the fact that with extended time comes more risk. Okay, the longer the term, the greater the risk, the interest rate risk, simply because if you go back and look at any historical records of interest rates, the longer the time frame, the more the change. And the reason is because the economy, changes and the market changes and everything changes in usually greater form with a longer term. And whenever there's unknowns, that's where our risk comes in. So that's why it makes, at least to me, logically complete sense that the yield to maturity, that the duration changes what our risk is. All right, spreadsheet 11.2. This is on page 333 in your book. We have settlement dates. We have our maturity duration, our coupon rate, our yield to maturity, and our coupons per year. So this one's not a semi-annual one. So the Macaulay duration versus the modified duration. And so you can see this is how the formulas are, and they have, I believe they have these formulas in Excel. equals duration. See, they have both the duration and the modified methodologies method for duration that you can configure and use those in Excel yourself. And again, I'm not going to rebuild this because I do believe they did a great job of building it right here and showing you step by step what exactly it looks like. So I'm not going to rebuild it, but this is, again, another good spreadsheet that I would recommend building. So what determines duration? So zero coupon bonds duration is time to maturity. The time yield to maturity is constant. The bond's duration and interest rate sensitivity are higher when the coupon rate is lower, which is why we saw the discount was more substantial on a zero coupon bond than an 8% interest bond that we saw 4 or 5 slides ago when we were looking at the first spreadsheet, 11.1, I believe. The coupon rate is constant. The bond's duration, the interest rate sensitivity generally increase with time to maturity. Duration always increases with maturity for bonds at or above par. All right, what other things determine duration? Other factors are constant. Duration and interest rate. Sensitivity of a coupon bond is higher when a bond's yield to maturity is lower. And the duration of perpetuity is this. So if it's a bond that we never know when it's going to mature, this is the function we would use for that. This is figure 11.2 in your book on page 334. It shows the zero coupon bond, which you see is just a flat straight line. And then you can see how our other yield to maturities, our interest rate differences, and our yield to maturity differences cause different curves of the line, even some that cross one another based on term as well. These are all, I believe these are all 30-year bonds though. Yeah, but it would change if you bought it in the middle. Okay, so if you got a bond that is a 30-year bond, but you bought it in year 22, then that's different than if you bought it in year 0 and had it for 30 years. So duration of annual coupon bonds, initial yield to maturity is 6%. So the initial yield to maturity in this table is 6%. And then we have the coupon rates for different bonds, a 2% coupon rate versus a 4% coupon rate. And notice that as we increase the maturity years, we increase the percentage in yield per year. And also notice that it's lower with the higher percentage bond here, and it's higher with the lower percentage bond. This is an example of, again, what we talked about, I think, at slide 3, where we talked about how the lower interest rate bonds tend to carry a heavier interest rate risk, especially with a longer yield to maturity. Or longer maturity time, I guess. Immunization. Immunization is a strategy to shield net worth from interest rate movements. So effectively, we're trying to build a portfolio for working with an immunization that we have enough elements in our portfolio that have an inverse relationship with the bond or with the rates of interest, and we have enough that have a direct relationship with the bond rate of interest. So while we have, since we have that, that would hopefully, if we've properly done this, hopefully mean that changes in interest rate prices leave my yield effectively flat, which is hopefully a positive yield, obviously, but effectively flat. Rebalancing is realigning proportions of assets in a portfolio as needed. So as we go along and we notice that things are changing, rebalancing, buying more, selling certain assets to rebalance, especially if we're going for something like immunization. Okay. This is the terminal value of a 6-year maturity bond portfolio after 5 years, with all proceeds being reinvested. So if the rates remain, so this is a 6-year maturity bond, and it's got a rate of, well, we got 3 different bonds that rates remain at 8%, rates at 7%, and rates increase to, so 8% is the current yield. So 8% would be what the yield to maturity is right now. What happens if rates fall to 7%, and what happens if rates increase to 9%? Gives you the change in the differential overall value of the bond. And really, we did this in the present value function before, This shows it over time where we were doing it at a single point in time. So we were looking in the last chapter at, okay, if the rate's 8%, what is my bond pricing if my market rate is 7, or what's bond pricing if my market rate is 9? So we were looking at an instantaneous type thing, like where we were buying and selling it that day, versus now we're kind of looking at it over the long term and seeing what the price and yield of that bond is based on changes as I am in process of actually owning that instrument, that investment instrument at the time. So this is the accumulation of vested funds. So this curve represents the growth portfolio that at the original interest rate. If the interest rate at time t, which is here, the portfolio value falls but increases thereafter at a faster rate, represented by the broken curve at time d for duration, right here. So this is a market value of balance sheets, again with bonds. If we have an 8% rate of interest, this is obligation would be, that's interest rate equals the market rate, so it's the same value. If I have a 7% interest rate, market interest rate, then my bond is worth more. Okay, it's at a premium. If I have a 9% interest rate, my bond is worth less. My obligation is worth less than the $10,000 face amount par value. Here's another example of immunization. It shows kind of what the goal is. Effectively, the goal would be to keep along this line, okay, as close as possible, which obviously the way the graph is. So the coupon bond fully funds the obligation at an interest rate of 8%. Moreover, the present value of the curves are tangent at 8%, so the obligation will remain fully funded even if rates change by a small amount. All right, cash flow matching, and that says deduction. The book says dedication. I think they mean dedication. I think this is a typo on the. It is dedication. It's a typo on the slide here. But cash flow matching cash flows from fixed income portfolio with those of obligations. So if we have a portfolio and we know that we're going to owe, say, bond payments, if we're the company that actually is selling the bond and using that, and bond interest payments, we can match cash flow from one to the other. A dedication strategy is a multi-period cash flow matching where we choose to select bonds that match our cash flows coming in with the cash flows that are going to need to be going out, especially if we have interest payments. All right, convexity. Convexity is the curvature of price yield and its relationship to the bond. And investors oftentimes like convexity because the more convexity, the greater price increases. Smaller price decreases when the interest rates fluctuate by larger amounts. So convexity leads to greater jumps when we have positive jumps in the interest rate and lower dips when we have decreases in the interest rate. So here's the bond pricing convexity, the change yield, maturity yields, maturity in percentages, and the percentage change in bond price. And here's the duration approximation here. Okay, just the last few things to define for this chapter. We're just about done with it, actually. Substitution swap, the exchange of one bond for a bond with a similar attributes but at a better price. And I actually have really good examples in the book. I don't want to just read the book to you, so I'd recommend looking on page 346 through 347. And after each and every one of these, there's a paragraph that gives you an example of what these are, so they don't make sense. I think those do a pretty good job of helping you understand what they are. Intermarket swap, switching from one segment of the bond market to another. A rate anticipation swap, so I'm thinking that the rates are going to change. So I'm making a change in my bond based on forecasts and what I think is going to happen. A pure yield pickup swap, moving it to a higher yield bond, usually with longer maturity. So switching from a bond that might mature next year to a bond that might mature 5 years from now, but it's returning a higher interest rate, generally because the market rates have moved. Tax swap is swapping two similar bonds to receive the tax benefit from it. And then a horizon analysis, forecast of bonds and returns, based largely on the prediction of the yield curve at the end of the investment horizon. All right, and then a fixed income investment strategy. Fixed income is where you'll see a lot more bond investment, and mainly because bond investment means bond payments. So you'll see people that are retired and people that want guaranteed form of income utilize them. So some things that they do, the firm respects the market prices to have value. The information cannot already be reflected in the prices, and the interest rate movements can oftentimes be very hard to predict. But if you can make investments and keep yourself with a relatively fixed income, then the usual goal is going to be to try and purchase things that have value that has not yet been reflected in the pricing strategy of individuals that are selling those bonds. So I think that's all I have for chapter 11.